This video is for the Unit 8 flipbook called Trigonometry. This section is found in, or this video is found in section 2 of this flipbook, Top Flap. And the title of this section is Right Triangle Similarity. And the essential question you see on the page right now, class, essential question is, how does the altitude to the hypotenuse of a right triangle create similar triangles? So a couple of math words here that we have to understand is, one is an altitude. An altitude is a line drawn from one side of a triangle directly across to a vertex. And so this line CD is called an altitude. When it says altitude to the hypotenuse, it means that the altitude is touching the hypotenuse, which in this case is AB. If you can look at this as one big triangle, ABC, the hypotenuse is AB, the altitude is drawn from the hypotenuse to point C, and an altitude also, class, has to be drawn at a right angle to the side that it touches. So in this case, you can see I have labeled a right triangle here. So the altitude on this triangle, let's write it. The altitude, let me get that to be a different color here. The altitude in this case is CD. So that's our altitude. Now what's interesting about a right triangle, ABC, is that when you draw an altitude to the hypotenuse, amazingly, you actually create three different triangles: the big one or the main one, a smaller one here on the left, and a smaller one than that on the right, and every one of those triangles is similar to the others. So what I want to make a note here for you is all three triangles are similar. And this is an interesting property of right triangles and altitudes drawn touching the hypotenuse. So to make this simple, class, because this can get really complicated. These problems can be very difficult to solve for most students. I'm going to try to break it down for you. If you look at this main triangle, we actually created three triangles. Let's label the vertices of these triangles. The first one is our main one, our original one, A, C, and B. The next one is the one over here on the left side. That also has C on top. It also has A to the left. But now our right angle is at D. And then the smaller triangle over here on the right side, that also has C as the vertex on top. D is also the right angle, and now B is over here. Let's mark some of the angles that we know. We know that angle C for the big triangle is a right angle. For this triangle, we know that D is the right angle. And for this triangle, we know that D is the right angle. And just so we know which triangle we're talking about, rather than say the letters, let's go ahead and name these. I'm going to call this one the large one. Let's call this one the medium one. Let's call this one the small one. So we have a large triangle, our main triangle, a medium one, and a small one. Now let's mark other angles that are congruent. Angle A on our big triangle is clearly congruent to angle A on our medium triangle because they're the same angle. So those are reflexive property, they're the same angle. And now take a look at our big triangle and our small triangle. They both share angle B as the same angle, so those are congruent. Now class, you know, if two angles of one triangle are congruent to two angles of another, then the third angle has to be congruent because they add up to 180 degrees. So since the large triangle and the medium triangle have an angle marked with a single mark, and they have an angle marked with a right angle, that means this angle right here, I'll put 3 marks here. I'm sorry, not 3 marks. That angle is actually congruent to B. And the same thing applies to the small triangle. Look at the medium triangle and the small triangle. They both share a right angle. They both share a double mark. That means this third angle, this top angle, has to be congruent to A. So now you see we've got 3 triangles, and they are all similar, and they all have congruent or corresponding vertices. Now, let's write our triangle or our similarity statements for these triangles. Let's go ahead and do this. I'm going to start off with the first triangle, the large triangle, triangle ABC. And that's going to be similar. Let's take a look at our medium triangle. A matches up with A, B matches up with C, and C matches up with D. So there's our first triangle similarity, or similarity statement. Let's try the next one. Let's look at the large triangle and the small triangle. So we're going to label the large triangle ABC again. Let's see what that matches up with. A matches up with C, B matches up with B, and C matches up with D. Let's fix that B. C, B matches up with B, and C is a right angle, matches up with D, the right angle. There's our similarity statement for our large and our small. And let's write a similarity statement for our medium and our small. Our medium, let's just call this A, C, D. And that triangle is similar to triangle. Let's take a look. A matches up with C. C matches up with B. And D, which is our right angle, matches up with D. Now all these statements are true, and every one is true because of the AA similarity theorem. And it says again that if 2 triangles have 2 congruent pairs of angles, then those 2 triangles must be similar. So here's a diagram that shows you all the similarity. Now I'll show you where this is going to help us solve this kind of complicated problem. If CD is an altitude of triangle ABC, find the missing measurements.